Hello guys, in today's video we're talking about second derivative test. Second derivative test is another method we use to find minima, maxima and point of inflation of a function. So now let's start with what we need to know about second derivative test. That's the rules of second derivative test. So for second derivative test, we say these are the rules of second derivative test. Things that you need to know. We have one. We say at maxima, the square y over the x square is less, I mean, is less than 0. Then we have number 2, at minima, the square y over the x square is greater than 0. Then we have number 3, at point of inflation, the square y over the x square is equal to 0. So these are what we can use to determine if a function, if a turning point is maximum, minimum, or point is a point of inflation. So anytime you are using second derivative test, we have to know this to be able to solve. I'm going to be showing the steps, the step-by-step processes you can use to solve second derivative test. The first step to solving second derivative test is you have to find the derivative of the function. So we say find the y over the x. That's the first step. So number 2, you equate the y over the x to be 0 and use it to find the turning point. So we say equate the y over the x to be 0 and use it to find the turning point. So the third step is find the square y over the x square. So after we have found our turning point, we now find the square y over the x square. Then number 4 now, we use the turning point, or we put in the turning point as our values of the turning point into the square y over the x square. Then number 5, use the values to determine the type of turning point. So when we find the square y over the x square, we now put in our turning point into the square y over the x square. Then we use our values to determine the type of turning point. What I mean by this is that if we have a negative dy over the square y over the x square, means is less than 0. It means that we have a maximum point. While if we have a positive that is greater than 0, it means that we have a minimum point. Now we have this problem. It says find the minima, maxima, or point of inflation of the function y equals to x cubed minus 12x plus 5. So I said the first step we have to do is to find the y over the x. So differentiating this, you have the y over the x is 3x squared minus 12. So now we have found the y over the x. We equate the y over the x to be 0 and find our turning point. So we have, since the y over the x is 0, we have 3x squared minus 12 equal to 0. So factorizing this, we have 3 into x squared minus 4 equals to 0. So we have x squared minus 4 is equal to 0. That's x squared is equal to 4. So x is equal to square root of plus or minus 4. So x is plus or minus 2. So therefore, our turning points are x equal to plus 2 or minus 2. So these are our turning points. X is equal to plus 2 or minus 2. So the next step we have to do is to find the square y over the x square. So the square y over the x square is the second derivative of this. So differentiate it again. So we have the square y over the x square is equal to, differentiating this again, we have 6x. So the next thing is that we put our turning point into the square y over the x square. And so we have, first we'll start with the first one. At x equals to plus 2, the square y over the x square is equal to 6 into 2. So we have 12. So the square y over the x square is 12. Now we keep that one. So we say at x equal to minus 2, the square y over the x square is 6 into minus 2. So the square y over the x square is minus 12. So at our turning points, x is plus 2 or minus 2. For plus 2 we have 12, and for minus 2 we have minus 12. So now we go back to the rules which I talked about earlier, that when we have at maximum the square y over the x square is less than 0, and at minimum the square y over the x square is greater than 0. So plus 2, is it less than 0 or greater than 0? Is greater than 0. So what can we say it is? We say we can now say therefore at x equal to 2 we have a minimum, and minus 12 is less than 0. So we can now say at x equals to minus 2 we have a maxima. So if the square y over the x square is equal to 0, that means we have a point of inflation. So that is just it. It's very, very easy. An easier way of solving finding the minima and maxima of a function. I hope you enjoyed this video. Please, I'll see you in my next video. Thank you for watching, and God bless you.